All right, geometry. Yesterday I posted a poll on Google Classroom. Just go ahead and give me some feedback there. If you haven't taken it already, just let me know what you're thinking. I'm just trying to make this a good learning experience for you guys. So your feedback, your criticisms are important here, okay? So just tell me what you're thinking, and I'll try to adjust if necessary. I'm on page 595, okay? We're going to look at example 1, okay? But above that, there are a couple of theorems there, okay? And it's pretty simple, okay? So let's talk about that word tangent. We had a tangent line from last week, okay? Remember, a tangent line is a line that touches a circle one time, okay? So if you look at this blue part here, right, and if it continued, right, if it just kept going, this would be a tangent line where it's touching right here one time. It's touching at the point of tangency where this green line touches the blue line. Okay, so basically the theorems that we're going to use today is that if a tangent line touches a circle, the point of tangency, which this green line is a radius, right? The point of tangency and the tangent line make a right angle, all right? It makes 90 degrees right there. It's perpendicular, okay? So, in example 1, okay, they tell us that the length of this red side here, the length of the red side, they said, was 13. All right, they tell us it's 13. All the way, by the way, from here all the way down is 13. Okay? It's a terrible, terrible angle, or triangle I just drew right there. There we go. All right. They tell us that this blue side down here is 12. And they say find BC, find the radius. That's this side, right? How much is this, right? So if we don't know, we'll just use an x, right? A variable. You could use r for radius if you'd like. Now this is something we already know, right? How do you find a third side of a right triangle? Remember, because it's tangent, it's going to be a right angle right there. If you look in your book, it does not have a right angle. So that's something you need to know. Tangent lines are perpendicular, right? They're perpendicular with the radius, the point of tangency. So the way we find x, if you haven't already guessed, is using Pythagorean theorem, which is a squared plus b squared equals c squared. Reminder that c squared is the hypotenuse, and the hypotenuse is opposite of the right angle. Okay, so 13 squared, b squared is 12 squared, and since we don't know what a is, we'll just keep it as x. So we have x squared, 12 squared is 144, 13 squared is 169. Go ahead and check my math on that on your calculators if you must. We will go ahead and solve this by subtracting 144. These cancel. I'm left with x squared equals, and I think 169 minus 144 should be 25. Now you guys know the way to get rid of this square, right? To get rid of this square is to do the opposite, which is square root. And we know that the square root of 25 is 5. So this radius right there, this x is equal to 5. Now, I want to go over a page to this is example 3 on 596, okay? And they're going to ask us a similar question, okay? A similar question. I'm going to use the same page. I'm just going to kind of divide it like that, okay? But on number 3, it says, how do you show that it's tangent, right? Can we prove that it's tangent? So in this first problem, they told us that the blue line was tangent. It was in the instructions, okay? Here they're asking, can we show it? Can we prove that it's tangent? Well, the way we prove it, again, is with the Pythagorean theorem. Okay, so, and you can see this, I think, in your book here. This is example 3, reminder. All right, so this side is blue and it's 9. And then they have this side down here, this green side, they have at 12. Okay, And then last but not least, they have this red side, which they are saying is 15. All right, so they say this is, they say it's 15 from here to here. Okay? So, remember, if it is tangent, this should be a right angle, right? It's asking, is 12 tangent? Well, let's find out. If it is tangent, it should be a right angle. And if it is a right angle, then we should be able to use Pythagorean theorem. Okay, so let's go ahead and try it, and let's see if it equals, okay? Let's see if it equals. So up there I have, let's say, 9 squared plus, 12 squared equals 15 squared. Okay, so we don't have a variable here because they gave us all three sides, sorry. So if it equals, it will be tangent, right? Because if it equals, it's a right triangle. If it doesn't equal, then it won't be tangent. So use your calculator. This is 15 squared is 225. 12 squared is 144. And 9 squared is 81. Go ahead and add 81 plus 144 in your calculator. It is 225. So in this equation, we got 225 equals 225. Is that true? Well, yes it is. So since it's true, this has to be a right triangle. Right? Because you can't use Pythagorean theorem on triangles that aren't right? It wouldn't equal. So since it's a right triangle, that makes this a right angle. And since it's a right angle, that means this green line is tangent. And this is the point of tangency. Okay. I want to try another one like this. Let's go over to page 599, please. We're going to look at problem. I got to get a new sheet now. We're going to look at problem 20 on 599. Next, let's find out. Ooh, where is that? All right, so problem 20. Yeah, it's kind of a shady looking circle. All right. Okay. This side is 15. This side was 5. And this side all the way was 17. So this is number 20 in your book. And the instructions say, tell whether AB, which in the book I think they label it as A, B, C. So is AB tangent to the circle? Well, it looks like it's touching the circle once. But it might also go through the circle and touch a second time. So we have to check it using the Pythagorean theorem. Reminder, if AB is indeed, if it is in fact tangent, then this angle should be 90 degrees, right? It should be 90 degrees at the point of tangency, point A. So if this was the right angle, right, if this is what we're looking at, that would make 17 the hypotenuse, right? So we have A squared plus B squared equals C squared. C would have to be 17, so I'll plug 17 in for C. A would be 5 squared, and B 15 squared. Okay. Remember, if they equal, it'll be a right triangle. So go ahead and use your calculator now as I fill these in. I think 5 squared is 25. I think 15 squared is 225. And I believe 17 squared is 289. Okay. Let's go ahead and add these. 25 plus 225 is 250. So the question is, does 250 equal 289? Well, clearly, those are not the same. They do not equal, right? This answer is no. It's false. Okay, so if they don't equal, is this a right angle? The answer is no, right? It's not a right angle. It's going to be something other than 90 degrees. And so if it's not a right angle, is AB tangent? Right? Because the question was determine if it's tangent. The answer would be no, it's not. And your proof is using the Pythagorean theorem. Okay, guys, I want you to try a couple of problems for me. I'm on page 598, and I want you guys to do numbers 7 and 21. If you have any questions, go ahead and leave your questions in the comments below. Good luck.